Hi guys, and welcome to lesson 5-7, subtracting linear expressions. Please make sure you have the following notes in front of you. What will I learn? Today we're going to learn how to subtract linear expressions and how to solve real-world problems by subtracting linear expressions. So again, just to recap on vocabulary, a linear expression is an algebraic expression in which the variable is raised to the first power. So what we were doing last week was adding linear expressions, but when we're subtracting, we're not going to be adding the like terms together, we're going to be subtracting like terms. And as with adding linear expressions, you can use models and zero pairs if needed. So the modeling is going to be a little bit different than with adding, because with adding, we drew a model for the first expression and then one for the second expression. But I'll show you in a second. With subtracting linear expressions, we just have to draw the model for the first, and we're going to be subtracting the second expression from it. Okay, so there are two methods. We can use models to subtract the expressions, or we can use the algebraic way. And just like with adding expressions, I'm going to show you both ways and we're going to practice both ways. But after you know how to do both, it's going to be your choice which one you prefer to use to solve the problems. So for the first one, we have 5x plus 4 minus 3x plus 2. So I'm going to do models for this first one. So it starts off the same. The first thing I want to do is I want to take the expression 5x plus 4 and model it. So I need to draw 5 positive x's. And they're positive, so I'll put plus, 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 plus. And then for my constants, I need 4 positives. 1, 2, 3, 4. Okay. So for the next part, we are subtracting the expression 3x plus 2. So we don't need to draw or model this, because what we're going to do is take this away from our original model. So it says to subtract positive 3x. So literally what I'm going to do is I'm going to get rid of 1, 2, 3 x's. And then it also says that we want to subtract. So we subtracted 3. And then we want to subtract 2 positives. So I have 1, 2 positives. And then your answer is going to be what you have left over. So I have 2 positive x's. So that means my answer is going to be 2x. And then I have 2 positive constants. So 2x plus 2 is my final answer. So we can also solve this problem algebraically. I kind of touched on that when we're subtracting expressions, it's a little bit different because of the minus sign here over in this one. We have to remember that with the minus sign that there's that invisible 1 in front of it. And with the addition sign distributing it to the second expression, that didn't change the sign. But since we have a negative here, we're going to need to distribute it and fix our sign. So I'm going to rewrite the problem without the parentheses. So to get rid of the parentheses, again, we have to distribute this negative 1 to each term. So negative 1 times 3x is negative 3x. And then negative 1 times positive 2 is a negative 2 because of our multiplication rules. So the next thing we want to do is write our like terms together. We have 5x minus 3x plus 4 minus 2. So with my x's, 5x minus 3x, I'll have 2x left over. And then with a positive 4 and a negative 2, the signs are different, so I will subtract and get 2. And I want to keep the sign of the larger absolute value, which is that positive. So my final expression is 2x plus 2. Again, notice I got the same exact answer that I did for modeling. Go ahead and pause the video if you need to finish writing this down. Okay, going on to the next example, again, we're going to use models, and I'm going to show you how to simplify using algebraically. So this one's going to be a little bit different with using models. I still start out the same. 3x plus 2 is the first thing that I want to model. So I'll have 3x's. Go ahead and draw that. And they're going to be positive. So put a little plus sign. And then positive 2. Okay, so what I want to subtract is I want to subtract 2 negative x's. But if I look over here, all I have are positive x's. I don't have any negative x's to subtract. So one thing that we could do to help us be able to subtract those is we could draw some 0 pairs. So I need 2 negative x's to subtract. So I'm able to add 2 negative x's. But to be able to do that, I have to add a positive x as well. So you can add 0 pairs. Okay, and then I'm supposed to subtract a positive 1, but I already have that. Okay, so now, again, to recap what I did is when I'm trying to subtract 2 negative x's, I didn't have any negative x's to subtract. So I needed to make those. So I drew 2 negatives, so one right here and one right here, but I can't just add 2 negatives and then that's it. I have to add its opposite, so I create a 0 pair to balance it out. So now I'm able to subtract. I want to take away the negative 2 x's, so I'm going to get rid of those. And then I'm taking away 1 positive, so I'll get rid of that. So looking at what I have left, I have 1, 2, 3, 4, 5 positive x's. So this would be 5x. And then I have 1 positive. Okay. So that should be my answer. Okay. Let me go ahead and show you algebraically how we would do this. Move this over a little bit. Okay, so again, we have this negative sign in between, and I want to remove the parentheses. So to do that, I'm going to have to subtract the invisible negative 1 to each term. So the 3x plus 2 is fine. But then I do negative 1 times negative 2. Signs are the same, so it's going to be a positive 2x. And then a negative 1 times a positive 1 is a negative 1. So now let's move our terms next to each other. I have a 3x plus a 2x, a positive 2, and a negative 1. So 3x and a 2x give me 5x. And then a positive 2 and a negative 1 give me a positive 1. So again, look at my results. I got 5x plus 1 for both of them. Again, just 2 different ways of solving. One is more visual and one is algebraic. Go ahead and pause the tape to write down anything else you need to write down. Turn the page. Make sure you have the following notes in front of you. Okay, so I'm going to do letters A through D with you. Notice it says subtract, use models if needed. I prefer to do it algebraically, so I'm going to do that for the first 2, and then the last 2 I'm going to show you just to recap how to do it with models, and I'll also solve it algebraically too so that you could see that you get the same answer. So for A, we have 7x minus 12 minus 4x minus 3. So again, remember we have that negative 1 that needs to be distributed to break this expression out of the parentheses. So when I rewrite it, I have 7x minus 12. A negative 1 times a positive 4x turns it to a negative 4x. And then a negative 1 times a negative 3 makes it a positive 3. So now I'm going to write my terms next to each other, my like terms. I'll have 7x minus 4x minus 12 plus 3. So 7x minus 4x is going to give us 3x, positive 3x. And then a negative 12 and a positive 3, the signs are different, so we definitely subtract, and I get 9. And then I want to keep the sign of the larger absolute value. So the negative has larger absolute value. So that's why we get 3x minus 9 for our answer. Example B, we have 8x minus 4 minus the quantity negative 3 plus 2x. Again, I'm going to rewrite and distribute this negative or this negative 1. And I have to do that to be able to remove the parentheses. Remember, when we're simplifying algebraic expressions, our goals are to remove all parentheses and to make sure there's no like terms. So I'm going to write the 8x minus 4. And then negative 1 times negative 3 gives me a positive 3. And then a negative 1 times a positive 2x gives me a negative 2x. So let's write our like terms next to each other. We have 8x minus 2x, and then we have a negative 4 and a positive 3. 8x minus 2x, keep the sign of the larger absolute value and subtract. Positive 6x. Negative 4 and negative 3, we're going to subtract because the signs are different. Keep the sign of the larger absolute value. So that's how we get 6x minus 1. And remember, anytime if I'm going through this too fast, go ahead and pause the video so that you can catch up and write everything down. Okay, so letter C, I will model it and then I will do it algebraically. Move this up a little bit. Okay. So we have negative 3x minus 5. I have to draw that first. So let me draw my bars. Oops, that's kind of small. Okay, so we have negative, negative, negative. There's negative 3x. And then I have to draw negative 5. Negative, 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 negative. So I have negative 3x minus 5. Okay, so what I'm going to do is I'm going to subtract negative 2x, and I want to subtract a positive 1. So very easy to subtract the negative 2x because I have 3 negatives to subtract from. So I'm going to take away those 2. So I'll have 1x left. But I want to take away a positive 1. And if you look here, I don't have any positive 1s. I only have negative 1s. So what I'm going to do is I'm going to add a 0 pair. I'm going to add a positive 1, but to be able to do that, I have to add a negative 1 as well. So now, as I try to subtract, I want to subtract that positive 1. I'll get rid of that. So what I have left is I have 1 negative x, so I'll write that as a negative x, and then I have 1, 2, 3, 4, 5, 6 negatives. So this would be my answer. Okay, to show you solving this algebraically, I'm going to rewrite it by distributing the negative. So I'll have negative 3x minus 5 plus 2x minus 1. So moving my like terms next to each other, I have a negative 3x, a positive 2x, a negative 5, and a negative 1. Negative 3 and a positive 2 you want to subtract to keep the sign of the larger absolute value. So there's your negative x. A negative 5 and a negative 1, keep the sign and add, and we end up getting the same answer again, just doing it a different way. Okay, for D, I'll model this first, and then I will solve it algebraically. So we have x minus 7, that's what I need to draw first. So 1 positive x, and then I want 7 negatives. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I'm taking away a positive x and 2 negatives. So this one I don't have to draw any 0 pairs because I have everything I need. So if I'm going to take away this x, that's 1 positive, and then I want to take away 2 negatives, 1, 2. And so what I'm left with for my answer is I have 1, 2, 3, 4, 5. I should have negative 5 as my answer. Algebraically, let's distribute. So we'll have x minus 7 minus x plus 2. So moving the terms next to each other, I have x, a negative 7, and a positive 2. So obviously those will cancel out, and then negative 7 and a positive 2, keep the sign of the larger absolute value and subtract. I got a negative 5. Guess what? Same answer, doing it a different way. Okay, so you can solve real-world problems by subtracting linear expressions. So this word problem involves subtracting linear expressions. I'm going to do it algebraically instead of modeling it, because if you look at your constants, 50 and 24, that's going to be a lot to draw. Okay, so it says the expression 8x plus 50 represents the total amount of money the soccer team earned from selling X t-shirts. So if the team had to pay 2x plus $24 in expenses, write an expression to represent their profit. Okay, so this is the total. 8x plus 50 is the total amount that they earned. And the 2x plus 24 is what they have to pay. So when you pay money, that's subtraction. So we're going to subtract 2x plus 24. So again, to remove these parentheses, I have to distribute the negative to each term. So when I rewrite it, I have 8x plus 50 minus 2x minus 24. Write my like terms next to each other. 8x minus 2x plus 50 and a negative 24. So 8x minus 2x is 6x. And then we have the positive 50, negative 24, where we're going to keep the sign of the larger absolute value, which is positive. And we're going to subtract 50 minus 24 is going to give us 26. So 6x plus 26 is our expression. So the second part, we're going to use that expression. It says if the soccer team sold 40 t-shirts, what was their profit? So all I need to do is take my expression and substitute 40 for x. And then order of operations to solve. So 6 times 40, I'm going to multiply first. That's 240 plus 26. And that will give me 266. And remember, it's money, so we need that dollar sign. So the profit is $266. Go ahead and pause the video if you need to finish writing this down. Okay, so now it's your turn. You're going to try these 4 examples on your own. It says subtract, use models if needed. You can do it algebraically. You can use models. You could switch between the two. You could do both ways for all of them, whatever your choice. Just pick a way or pick both. And start working on these, and you will go over them as a class in just a few minutes. Thank you.